and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of the channel. Day 8. Resonant Collinearity. You find yourself on the roof of a top secret Easter Bunny installation. While historians do their thing, you take a look at the huge antenna. To your surprise, it seems to be reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as a Christmas gift. Unthinkable. Scanning across the city, you find that there are actually many such antennas. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map, your puzzle input, of these antennas, for example. The signal only applies its nefarious effect at specific antinodes based on the resonant frequencies of the antennas. In particular, an antinode occurs at a point that is perfectly in line with two antennas of the same frequency. But only when one antenna is twice as far away as the other. This means that for any pair of antennas with the same frequency, there are two antinodes, one on each side of them. So for these two antennas with a frequency of A, create two antinodes marked with hash mark. Adding a third antenna with the same frequency creates several more antinodes, which identically add 4 antinodes, but 2 are of the other side of the map. But 2 are off the right side of the map, so instead it adds only 2. Okay. Antennas with different frequency don't create antinodes. A and A count as different frequencies. However, antinodes can occur at location that contains antennas. In this diagram, a lone antenna with a frequency capital A creates no antinodes, but a lowercase a frequency antinode at its location. The first example has antennas with 2 different frequencies. So antinodes they create look like this, plus an antinode overlapping most A frequency antennas. Because the topmost A frequency antenna overlaps with 0 frequency antinodes, there are 14 total unique locations that contain an antinode within the bounds of the map. Calculate the impact of the signal. How many unique locations within the bounds of the map contain an antinode? Now I need to figure out a way of storing these nodes, figuring out a way of calculating the antinodes, and also figuring out how many is contained inside of the mapping area. We will take the lines and we will create nodes, and I think we will have a set of points. New hash set. So there we go. And we don't want to use the AVT points. We want to make our own new class points. There we go. And we want to create a set. So for each string line where we have lines, so this should be a y coordinate, y plus plus, and then we do for string character new string line split or anything, and in here we also want to have x value, x plus plus, and points. We'll add a new point with the character x and y value. So let's create that constructor. We have a string of character. There we go. Now we have created a bunch of points. So now we need to figure out where the anti-points are. Anti-points. Point in points. We loop. Point A and point B. So we have 2 points list. If point A equals point B, then continue. No reason to check if we are the same point. That won't give anything. And point A get anti-points, point B, and we get, then we have anti-points, and we add that in there. And we also need to figure out the width and the height of these. So let's say int width, int height. So this is lines size. This is lines get zero size or length. So now we have a width and a height. So when we get an anti-point, we send in height and width and height as well. So we know where an anti-point could occur. So first off, if so we need to be able to return null as well. So new point like that. If new point is not equal to null, we add new points. So if point character doesn't equal this character, then return null. So that's one thing. Okay, so equals this character not. So there we go. And we want to return a new point with the character of hash mark start there. So if they are the same character, then we will calculate an x being point b x minus this x. So that's the difference, dx. And then we want to add that to point b, right? So x would be point b x plus dx. So that's our x. And then we do the same for our y. Why? Tell me why. So that could be a minus value as well. But we also want to check if x is less than 0, then return null. If y is less than 0, then return null. If x is larger or equal to width, then return null. If y is larger or equal to height, return null. So now I have a bunch of criteria here, and we want to do antipoints, size, print. Let's see what we get. And we get a bunch of values. It's day 8. So that's not true. We have a bunch of points here. That's not true. We added a bunch of points, but the points that we shouldn't add, of course, if character equals a dot, then continue. I wonder if we can just draw a map. That might be the easiest. Now it should crash sometime. It doesn't. That's interesting. Now I'm just curious to create this this map, or draw this map, because this is just weird. We should have a problem, right? Fy then, like that. Phi. Oh, okay. I figured it out pretty easily, and I guess you were screaming at your screen as well. Can't do it like this. Of course, we need to increment the x value each time, or else it doesn't make sense at all. Now we got 15 again, but the values at least are spread out. And I would say that these up here are correct. So this one is one where there is another point. So it's an antenna point. So, let's check the other ones. So what we don't take into account here is if we have another point already in that position as an antipoint. For each point in point here, and points contains new point. If that is not true, then we can add it. So now in order to make it contains, we need to add a couple of functions here. So we need to add, let's refactor, generate. Let's generate. We need to generate equals and hash code. Like that. Let's just generate them as is. So I wonder if that just works for us. Then we get 14. So, and let's verify that we have the map still contains the incorrect point in my mind, but the calculation is correct now. So that's weird. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I don't get it. Let's try the real one and see. We got 247. Let's see if that is correct. Yes, you got a gold star. I got a gold star. Everybody gets a gold star. The result is just weird because I can't figure out the right positions, but I guess it just strange. So let's hide this map here because we might not need that. Let's read the second one. Part 2. Watching over your shoulder as you work. One of the historians asks you if you took the effects of the resonance harmonics into calculation. Whoops! After updating your model, it turns out that an antinode occurs at any grid position exactly in line with at least 2 antennas with the same frequency, regardless of distance. This means that some of the antinodes will occur at the position of each antenna, unless that antenna is only one of its frequency. So these 3 frequency antennas create many antinodes. In fact, the 3 frequency antennas are exactly in line with 2 antennas, so they are all also antinodes. This brings the total number of antinodes above to 9. The original example of has now 34 nodes, including the antinodes that appear on every antenna. Calculate the impact of the signal using this updated model. How many unique locations within the bounds of the map contains an antenna? I think we will take this day 8 and make it into a B. And then we need to have a list of points return. And then we have get antipoints. And we add all antipoints. No, we add one antipoint. And here we have a 4 point, new point, list of points, list of points. So here we can add each of those. So if they aren't null, which they never will be, or if it doesn't contain that, then we add them. Here we will create a list of points. So copy that over like that. Now let's do stuff here. So this is something that we need to do multiple times. So int x x. So this is our starting x and our starting y. While x, we will continue. And we will have this list of points, new points, new array list, return new points. So now we have that settled. So here we have the initial value. So that's the first point. New points. We'll add that one. And then we will update this. So we will pretty much take x and y and we will add the difference. Like that. And hopefully we will end up with the right amount of points. Got a null pointer exception. Okay, of course. We want to have a new array list here instead, because that's reasonable. We got 0. No points. Oh, it's all of this is the other way around. So we want it to be larger than -1, and we want it to be less than width or height. Of course, we want it to be inside of the area. Then we get 29. And we should have 34. So that's not true. So is that correct? 36. No. The problem with this one isn't really the calculation as much as actually figuring out what they are looking for, because that is the this weird part here. Let's the text is the hardest part, I would say. Count plus equals to this thingy, and if that's equal to 1, then now we can just add it up, because it's 1 and 0. It's so nice. And then let's print count here. We get 34, I hope. Yes, we got 34. Let's just print out the real result. It's 861. Let's see if that is correct. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So this one was not complicated from an implementation view. It was complicated from understanding the text view. So I'm not really sure what they were after when they wrote the text, but I implemented something that spit out the right value. So I'm not really happy about this one, because it was needlessly complicated. Did you like this one? Give it a like, share it with your friends and colleagues. If you have any comments or suggestions about this Leave those in the comment section down below, and I really want to see your solutions, so leave those down there as well. If you haven't subscribed yet, please do that, and I really hope to see you in the next video.